Hello to everyone attending both in person and virtually. Today we'll be talking about MAP, or Models of Applied Privacy, or how to do privacy threat modeling for an application using a personas-based approach. My name is Jayati. I am a privacy engineer, and this work was done in collaboration with my colleagues at the Spider Group in Comcast, Bahman Rashidi and Vaibhav Garg. Suppose you're a product developer, you know how your application works, and you know what kinds of assets and data are part of your application. To find out if there are privacy threats from the application to stakeholders, you can typically conduct a privacy threat model guided by the architecture diagram. However, there are a couple of roadblocks. Typically, threat modeling is done by an assigned team of privacy experts. By the time an application gets to that stage, majority of the development is usually complete, making it harder to mitigate threats. Furthermore, these sessions are resource intensive. They need time and specialists, which can make privacy by design costly. Additionally, threat modeling is often art, with different modelers choosing different ways to represent threats. Inherently, this requires a degree of privacy expertise. What we need is a framework for us to shift left, to help developers find and understand privacy threats in their application. This would make the process visible much earlier in the software development lifecycle. Furthermore, it would supplement threat modeling by reducing the overhead for threat modelers who might be handling several applications. Having a framework with common language that is consistent across applications helps not only with better threat metrics, but also increases organizational knowledge of these threats. Furthermore, it provides developers with enough expertise to search for some threats themselves. To this effect, we build on existing frameworks like Linden, the NIST Privacy Risk Assessment Methodology, and the Taxonomy of Harms, among other sources, to create a holistic framework that complements manual privacy threat modeling. MAP can be used in two ways. First, by threat modelers to classify their existing list of threats, and secondly, by developers to find threats using personas. The structure of the framework, which we discuss in a bit, gives enough information to a developer to understand not only who can cause a threat, but also what the threat is and what effect it can have. It contains three components: the threat actor, which we derive from CSAN's threat actor list and classify for broader applicability, threat mechanism, which we derive from Linden and PRAM, and impact, which we derive from the taxonomy of harms and then classify. Let's start with threat mechanism. Threat mechanism defines the different possible paths in which threats can occur. For example, if the information flowing through an application can be used to identify a person, it is an identifiability problem. MAP currently lists 10 such mechanisms. The second components are actors who can cause a threat. As you can see, we have categorized actors based on whether they are present inside or outside an organization, thus changing what they can access. The other categorization is based on whether they can intend to cause harm to an organization or to a person. These result in 4 subcategories, which are further divided by expertise. Therefore, an outside neutral expert actor would be a researcher, for example. The third and final component is threat impact, the harm a privacy threat can cause. We divide harm into 2 categories, organizational or individual. We further divide these harms as explicit or implicit based on whether they can be measured or not. Combining the three, we get an overall privacy threat modeling framework. To know more about each category, you can visit the GitHub repository link given at the end of this presentation. The structure of the framework allows categories to be added or deleted as required. It is piecewise and hence scalable for applications. It can be customized based on the application type. And finally, it also moves away from an attacker-only approach. because privacy incidents are not only caused by actors who have malicious intent. From this abstract framework to a more concrete visualization of threats, we use personas. Personas are fictional characters who represent the different user types that might use your service, product, site, or brand. In our case, we use threat personas to find cases for misuse. We use personas based on our threat actors from MAP, doing problematic actions that result in a privacy harm. The combination of these three elements cause a privacy incident. Let us look at how this works. In this example, based on the Strava breach that happened a couple of years ago. Let's consider the actor to be a researcher named Orange, who is present outside the organization and is a security expert. Orange finds that route data from users are available publicly and their concentration can reveal the location of military bases. This unanticipated revelation can cause reputational harm to an organization. Of course, this is one of the types of harm that can happen. Notice that we are more focused on what the persona does than who the persona is. Now it is up to the developer to determine whether this is a persona that will apply to their system. Another example could be a college sophomore named Pineapple who uses a tracker to find physical objects. They use this tracker to track a person's car because it can correlate a person to their location. This can lead to a physical harm with the threat actor potentially breaking and entering. The application of these personas is very simple. Developers review their application, review the map framework, and then select some of the subcategories that they think are relevant. They then pick one choice from each of the three major categories and create a combination. This gives a persona. If this persona applies, this becomes a potential finding for mitigation. Developers can also choose to discuss their findings and mitigation strategies with threat modelers, helping them as well. Note that security threat model is always the first step. Now that we know how to use map and create personas, we are asked if we can show a use case of real-world incidents of personas using map. From a sample of 207 incidents from the VERIS Community Database or VCDB, 183 incidents, 88.4%, matched the framework categories. 24 did not match, which is 11.6%. Among these 24, 17 breaches did not have enough information about the threat actor or mechanism. The remaining 7 incidents could not be categorized into a threat mechanism since they occurred due to an error. For example, a fax was sent to person A instead of person B. Of course, as our threat landscape expands, we can keep adding more threats to the framework. The flexible nature of MAP allows it. Among the 183 incidents we classified, here is a breakdown by actor, mechanism, and impact. The highlighted numbers show categories that sum up to over 80% of the incidents. It is interesting to see that employees and related entities, both present within an organization, account for over 80% of privacy incidents. The top 3 mechanisms of privacy threats are non-compliance, disclosure of information, and identifiability. Finally, for impact, threats disproportionately impact individuals more, as we can see, causing loss of autonomy, economic loss, and psychological harm. Reputational harm to organizations caused by privacy incidents also form a large portion of the harms. With that, we wrap up our session. To sum up, we present a unified framework to conduct threat modeling in organizations that leverage the use of personas. This framework builds on existing literature to help classify privacy findings for applications. Our open source project is available on GitHub, and additional research by our research team can be found at the given link. Please feel free to reach out to us on LinkedIn as well. With that, we are happy to take any questions online or offline. Thank you.